All right, just a quick greeting to our soccer players. Hi, soccer players. I hope you're having a great time. And as you listen to this, I hope that you're already celebrating a victory. So that's going to be really great. It is not live. It is recorded. It will be on YouTube. So there we go. Hello, YouTube people. So all the subscribers that are out there as well. This is a recording of the class that is happening as it goes on. And we're going to look at solving systems of graphs by graphs and tables today. So as we go along and as you learn things, I'm hoping that this will come out to be really a good thing for you all. Okay, so a system of equations, okay, is not just one linear equation, it's two linear equations. Well, it actually doesn't have to be linear equations, but we're starting with linear equations. So two equations that would make a line, and when you're looking for the solution, you're looking for where they intersect each other. It's the ordered pair that makes both of those linear equations true. So the other thing that could happen is you could have a pair of parallel lines, and if they're parallel, will they intersect? No. So since they're not going to intersect, there's going to be no solution to them. So we have that we can also have as an option. But the first one we're going to take a look at is going to have a solution, because otherwise it would just be kind of lame to start with one that didn't have a solution. So what we want to do is we want to first of all, for these, we want to put them into slope-intercept form. So what does that mean? Good. So y equals mx plus b form. So let's go and let's do negative 3 plus 2y equals 8. Negative 3x plus 2y equals 8. That is the first equation, right? Make sure I wrote it right, because I had to switch between. So we want to put it into mx plus b form. So what do we do? What's our first step? Good. Add the 3x to both sides. So we'll do that. So 2y equals 3x plus 8. And then you need to do one more thing. Divide by 2. So when we divide by 2 and we simplify it, we get y equals 3 halves x plus 4. All right, and what I'd like to do is I'd like to bring this over to our graph that we're working on. So I'll just copy it and move it over here. Paste it in here. There we go. So we have this. This is our y equals mx plus b form for this. We need to put this one also in slope-intercept form. So we'll go back over here where I can write more efficiently, and I'm doing x plus 2y equals negative 8. So x plus 2y equals negative 8. And so our process is we need to do what? Good. So we'll subtract the x. Minus 8. And then we need to divide by 2. So y equals, good, negative half x, or x over 2, but just so long as you're realizing that it's your slope is negative a half here, minus 4. Okay, so once again, I'll move this over so that we can have it right there in front of us. All right, we need to do graphs now. So for your graphs, don't forget we need an x-axis and a y-axis. So we're going to put these in here. Now because we're trying to find the solution, trying to find the place that it intersects, for these type of problems it's not optional to use graph paper. You absolutely positively have to, because if you're doing the thing where you're just doing an estimated graph on your notebook paper, you're going to miss exactly where they intersect, so you've got to be super careful here. So here we have y equals 3 halves x plus 4. So where do you start this graph? Oh wait, we made a mistake. No, we didn't. Okay, sorry. Start at 4. 0, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there's our 4. And then we need to, over how many? It's rise over run, so we go up 3, 1, 2, 3, and then over 2. Now that's great, but we need more points than that. So then how do we find more of them? Down 3, left 2. Good. Down 3, left 2. Wow, it's hard to see from here. Down 3, left 2. So we've got this. This is our nice starting line. So we've got this coming like here. You're going to make your nice straight line that goes through them all. Understanding that we're doing this super carefully, because notice that at the very end there it kind of tilted accidentally a little bit off. But if it's a little bit off, especially since we're looking for intersects, we're going to have a problem. So we've got to make sure that our line is nice and straight going through those ordered pairs that we just very carefully plotted on there, so that it's always down 3 over 2, so we can see where they actually are. Here's another one right here. All right, now the other graph. Taking a look at the other graph, where do we start graphing this one? 0, negative 4. So we're going to put a dot here at 0, negative 4. 1, 2, 3, 4. And then for that one, we will go which way? Down 1, left 2 or right 2? Right 2. The numerator tells us how far up or down, the denominator how far right or left. Now negative 1 over 2 is the same as 1 over negative 2. So you could go up 1, left 2, but if you go down 1, left 2, that's negative over negative, which would make positive 1/2, which is not what we need to do, so be careful of that. So when we start doing this and then we go the other way, we do find the intersection, okay, right here. We do want to actually finish the graph so that we can see what's happening here, because I do want to make the point that, you know, we're looking for the intersection. So what is the intersection of these two graphs? What's this? Negative 4, negative 2. Good. So negative 4, negative 2 is actually our solution to this problem. Yes, as a matter of fact, in order to check it, what you would do is you would plug it back into the original equations to make sure that it made both of them true. So if I plug this back into the original equation, and I'm doing negative 3 times negative 4 plus 2 times 2, we're expecting that to equal how much? 8. We're expecting it to equal 8. So this would be negative times negative, negative 2, right, negative 2. And you know what, that's a great example of why it's important to do the check, because even though when the solution was given, someone said negative 4, negative 2, it's very easy to write down the wrong thing, and then when you plug it in, then you can check, double check to make sure that you wrote the right thing down. Negative 4, negative 2. So it's the whole ordered pair, negative 4, negative 2, because that's where they intersect. And it has to make both of these true. So here's the first one. We actually plug in the negative 2 rather than the positive. We get 8. And then our x, we plug it into the second equation, negative 4 plus 2 times negative 2. We're expecting that to equal negative 8, but we want to double check and make sure. And so it does equal the right thing, so both of them checked out, and that is really how you make sure that you have the right answer at the end. Yes? Yes, because it is possible for you to do something wrong and you get a solution that works in one of them but it doesn't work in the other. Like if you made a mistake on your second graph you would still have an answer that worked on the first graph, but it wouldn't work in both. So you've got to make sure that you're careful. And then that double check at the end makes sure that you didn't make some kind of a mistake. In this case, it was forgetting to write the -2 even though we knew it was there. But then also, it gives you a chance to just make sure that you did everything correctly. All right, so I had all that written out nice and pretty, but it definitely helps to do it as we go along. There's our solution, and there's my instructions to go ahead and check it. So another way to solve these can be to use your calculator with a generated table. Quite honestly, I'm going to show you how to use a generated table so that you know that it lives in there, so that you know that that's a resource that you can use. But there's going to be another method that we can use with the calculator that's going to be much easier. We need to run this through because I want you to know all about your calculator, but it's my least favorite way. And when you actually do more problems and you learn the other way, it's okay to like that one better. But we do need to see what your calculator can do for you. So just like before, you need to make sure that you're writing your equations in slope-intercept form. So this is the same problem, so we don't have to go through the steps again as far as writing that, but what we do need to do is work through your calculator steps like on the sheet in front of you. So you'll need to pull up you need to get your calculator out. If you don't have it handy, you can get that. And so when we enter the equations, we need to, first of all, which I don't have here, remember how we were using your stats, your plots? We need to make sure they're turned off. So just to make sure that your plots are not getting in your way, go to the second y equals. Remember we turned the plots on. We want all the plots off. So the easiest way to make sure that all the plots are off is just go down to option 4 and turn the plots off. And then everything's off and you don't have to worry about that messing up your graphs, messing up your, it can give errors and things like that, and we don't want to have that as being an issue for you. So we then are going to push y equals, just y equals. And it should be all nice and clean here in your equations, but if you have any leftover equations that are hiding there, just push the clear button and clear out any equations that might be hiding there so that you have just places to put in your two graphs that we want to look at. So we're going to put in 3/2 x plus 4. When dealing with fractions, the best practice is to go ahead and put them in parentheses. So to get 3/2, we would do 3 divided by 2. And there's your fraction. Your x key is right here next to the alpha button. It's got all these things on it, but just pushing it once is going to give you your x that you need to have, and then plus 4. And then you use your arrow key to go down to your second y equation. And once again, I want to put my negative. Be careful, there's a difference between the negative and the minus key. So use your negative key. -1/2 x minus 4. Some common mistakes I've seen people do is people forget to put the x. If you forget to put the x, then you're going to have something that doesn't work out right. One good thing is we've done a lot of graphing, so you know what to expect of your graphs. So if your graph looks really weird, like why does it look like that, then you might have made a mistake. Next thing we want to do is we want to actually take a look and see what that graph is going to look like. I have on the directions to push second graph, but I think the better thing, I want you to correct that and write zoom. And then 6. Zoom is a thing that tells the calculator I want to do a graph and I want it to look like a certain thing. So we're going to change that direction to push zoom, and 6 is our standard graph. There's other graphs that are good for other things, but I want to choose option 6. And that's a good way to see what a graph looks like to start with. So there's our graph. Okay, so you now see the one graph and the other graph that we just took our time with. What's that? Yours is different. So if you have a different graph, go back to your y equals and double check to make sure you put that in correctly. Because it's very easy to forget a negative, or it's very easy to forget to put a plus or a minus. Make sure you've got that looking exactly like that. And if you do, it should be coming out with the right graph. 6. Zoom 6. And let me look. Wow, I have never seen a calculator actually with the right equations put in give the wrong. Oh, I see. Right there. When you're doing, just so everybody knows, when you have this, don't put a negative, put in a minus, because when you put a negative here, what it's really doing is multiplying -4 times -1/2 times x instead of subtracting it. So putting in the minus button, the blue minus button when you mean minus, and the negative button when you mean negative. And it's very subtle because this one, when it's put in incorrectly, looks like a little tiny minus like this one. So just be really, really super careful. So when you do the zoom and you do the 6, this is just for us to see what's happening. We see that that does that. But the functions that we're going to actually do is we're going to take a look at the table involved. And the table is found at the second of the graph. So we do need to press second and graph. I did want to show you the zoom so we could see the graphs, what they look like. But we want to look at the tables. And when we push second graph, notice that we now have a table that has x versus y1 and x versus y2. And if you want to find the solution, you need to actually use your arrow keys to find where the x and where the y's actually are going to match. So you're looking for where, when we're going this way, what we're noticing is that the y's are getting kind of further and further and further apart instead of closer together. So if we can use our arrow keys, we can keep on searching until you find where the two y's match each other. Now sometimes it's hard to figure out where the two y's are going to match each other. So this is, like I said, not my favorite way because the graph is a lot more intuitive as far as what you're looking for. But -4, -2, notice that since the y's equal here, -4, -2, -4, -2 is on both graphs. So this is an alternate way. You can look at the tables. It's also a good way, because some of you like to graph by table. So it's also a good way that if you're doing a by hand graph, if you put your equations in, you could generate a table of values just by looking at that, and then you could use that to do manual graph. So it is useful for that. More than this, but just so you can understand at another level, this is where -4, -2 lives, and -4, -2 also lives. So we've added in that you can see the graph if you want to with the zoom button, but we can also look at the table by doing second graph and looking at the table. Yes. How did I get the table? Push second, and then this button up here says graph. And when you do that, we get a graph. And if you, like, okay, so say somebody was messing around with your calculator and they just were pushing the up and down button and got you all the way to like 85 or something like that. If you want to, you can then just do a y and x equals, if we can figure out how to get to that, although it's kind of a pain. I thought we could do it by arrows, but we can't. So you may just have to scroll back and forth. I know it's in here. I'll figure it out for you for tomorrow and add that as something to do. But 2000. 2016. Of course it is. So let's um wow. Okay, so I'll get back to you on that one. Okay. Actually, hold on a second. All right, so just back to what we were talking about a second ago. If you do need to reset that table, you go into second window and you can set where you want the table to start. So if you had gone to like 5,000 or something like that, like somebody was messing around with it earlier, and you just want to look at what x equals 2, you can do that to change your table start place, and then second table, and it goes back, and then that'll be the starting value on it. So anybody that does have something like in the thousands or something like that, you can fix it to make sure that your table's starting at the right place. Second table, so we've changed that. You just put the other number in. You really don't even have to push anything. I pushed enter just to get it so you could see it. But as soon as you've changed that number, like say I wanted to find 5,000, and our bell is going to ring in just a minute here, but if I wanted to start at 5,000, I could. And then I could go over to our table. I could go to our table because it didn't register. There we go. And then it starts at 5,000. So you could do whatever you want to see those. So that's kind of cool. And we'll finish this up tomorrow. It's not critical because I wanted to take our time on this. And soccer team, hope you're having a great time. And that's it. Bye, everybody. Have a great day.